Hello, welcome everyone to my fifth mini lesson and welcome year 8. Today we are going to learn fruit and vegetable battery manufacturing. It's basically a fun to understand how we can develop electrical energy. This is a part of physical sciences. Before going to the PowerPoint presentation, I would like to describe you that's what we are going to do in today's lesson. Today we will discuss initially about how a battery can be built using the lemon, potato or surrounding vegetables. And I will explain the principle of battery and then the fun parts, which is the exploratory investigations of making battery. Okay, so we have to do the work in a group. So each group will have 4 students. As we have 24 students, we will prepare 6 groups. All right, so what I would like to suggest at this moment, you already know that's how we did the group activities. So I'm not going to make another group. I would like to work in the same groups as all the students present today's lesson. So let's sit together in your group and feel free to ask any question during the lecture because you need to do the same thing. And the good things, I will demonstrate you what you have to do for one fruit, but your task to use another 9 fruits. All good? Okay, now please sit down. 4 students in each groups and let's start our main lesson. I'm going to share the skin for you. Okay, all good. Hopefully you can see. Okay, so there's a plenty of battery. Everyone can identify. Anyone can see. So group A, B, C, D, E, F. So 6 groups. You see that's multiple battery. Oh, you're saying Tesla. Oh yeah, that's the maximum. That's the best battery manufacturing company. And do you know in South Australia we have a power plant that's developed by Tesla, which is 300 megawatt. That's the biggest battery in the world. Oh, that's no, you're brilliant. Great. Okay. So battery is everywhere. Now, do you know how the world's first battery has been made? So battery is very simple. They should have two dissimilar metal like zinc or copper. You know this, right? So I can show you zinc and copper. That's during the experiment. And that has been developed by an Italian scientist, basically the physicist, because the scientist worked with the physics. His name is Alessandro Volta, and according to his name, we say the unit of batteries that's developed units of energy is volt. So this is a respect to him. And interestingly, the electrical signal, that's electrical energy that is expressed in terms of volt, has been discovered in 1827, almost 200 years ago. Okay, so you see, the world's first battery, how Alcendo Volta has been discovered. So I'm going back. You see, that's it's basically two frog leg has been connected with two metal strip, and that's why it's developed two dissimilar voltage. You know voltage, right? We did discuss last week. Now I will show you how to measure the voltage. It's very easy. We can use the multimeter. Multimeter can voltage and current. So we can measure both, or we can measure at least voltage. So it's funny, right? Okay, now world's largest battery. That's the biggest battery in the world. That's like the football piece. However, this figure I have picked from the website of Tesla, but the world's largest battery that has been in operation in 2020, just this year, which is not in Alaska, which is in South Australia. But before South Australia, it was in Alaska. Okay. Now the world's smallest battery. Anyone can tell me where we can see the world's smallest battery? Anyone have any experience? No? Yes? Group E? Oh, you know. What is this? That's heart surgery. Oh, yes. It's not bypass surgery, but some people did have differentiated rhythm in the heart. So the heartbeat is fluctuated significantly. That's why the cardiologist, basically the cardiac surgeon, put a device in the heart to regulate the heartbeat. And there is a very small battery. It's like the needle, right? That's And there is also some battery that stimulate the nerves and muscle cells inside the human's muscles, because some people's muscles have been stuck. I don't know in detail, but I know a little bit because I had to go through heart surgery at some point of my life. So I know very little. Uh, but I hope that when you will be a cardiac surgeon, you will learn a lot, or you will be the biomedical engineer in future, right? Okay, so that's interesting. The fruit battery. Fruit battery is very easy. You see that we have the citrus fruit. There is a lot of lemon, lime, orange, mandarin, lot of things. So the citrus fruit is consist of citric acid. So it's basically the electrolyte that will convey the voltage from zinc to copper. So different electrode. Okay, so two different things I will discuss through this. That so we are talking about the electrode and electrolyte. Electrolyte is basically the liquid. So what we'll be doing, we'll be connect the crocodile clip with uh, with the fruits, or you also have to use some sort of vegetables like potato, carrot, and you need to identify which one will be the best battery in terms of developing voltage. So you need to write down the reading from the multimeter. Although I have written it's a voltmeter, it's a voltmeter can only measure voltage, but multimeter can measure the voltage and ammeter and current also. Okay, so this is the result sheet. It's pretty straightforward because there is not a lot that's you could do, because I intentionally make the system easier. Like you will be use the copper, aluminium, iron, and zinc. That the electrode, you can see that the copper is some sort of reddish color. Aluminium is like the silver color. Iron, this is a stainless steel, right? So it's basically steel, so steel could be called iron. And you know, zinc is utilizing a lot of times because it's a very good electrode. Okay, now what you have to do? You have to do the same thing. You need to put the strip into the lemon, okay, as I shown into the video, okay. And left side here I have put the copper, and this side is zinc. All right, so copper and zinc has been connected with the wire, and then this two end will be connected with the ammeter, and you can easily measure the voltage and current, but the current is very, very small. So I would like to fix the current of the ammeter so that you can get in different volt. Okay, so I am going to supply you the sheets, which is basically you need to, in this table, you need to write down different voltage. That's from different experiment. Okay, now one safety things always have to maintain, although it's very, very safe, the amount of voltage is not too high, so it doesn't matter if you did touch the current, it will nothing happen to the human body. But the metal strip is bit sharp, so you have to be very, very careful. You are not going to cut your hand. Okay, so you have to be careful. All right. And in other way, you always need to take the safety goggles, because you know that citric acid or sometimes metal strip can become come into the eyes, because eye is very important. That's why we always take the safety goggles. Safety first. Okay, when you will get, I will show this demonstration as I'm going to show you just after a minute. When you will get potato, you have to do the same thing. Not only potato, the rest of the fruits. All right? Okay. Now, do you have any questions? Group A, how many experiments? Oh, yes, good questions. We have planned, as we have 10 fruits, we are going to do the 10 experiments, because although the same experiment, but using 10 different fruits. So we will have 10 different cases. Okay. Now, some guys need to do the experiment. Some guys need to record the data. What I suggest is strongly, you can do it in a rotational mode, because everyone will have some experience to do the experiment. Everyone will have some experience to the measurement and data recording. What I did suggest, as you are 4 students, 2 students will do the experiment and 2 students will record the same data, because if you see the data is not same because of the human error, you can do the experiments again. That's it. This is the scientific way. We cannot believe on only one recording. That's why 2 students need to record the data. Do you understand? In that way, 4 of you will be involved with this experiment. All right. Any other questions? No questions. Okay, I have some questions. You need to understand, how did the fruit produce a voltage? How? Did you think about this? Dissimilar metal? Yeah, but the dissimilar metal, I have 2 dissimilar metal here. There is the same voltage. Okay, because it's in the same environment. Okay, yes, dissimilar voltage, but it has to be inserted in electrolyte. That could be coming from the fruits or vegetables. Okay. Next question. Why don't we use fruit instead of batteries? That's a good question, isn't it? So we have the fruits in our fridge, right? So why we need to buy the battery? Like your smartphone, why you need to use the battery? Because fruit will be molding. Okay, it will be rotten, it will be damaged, and we will get very small amount of voltage. While the battery, particularly the smartphone or any mobile phone, did use the lithium-ion battery. Lithium-ion battery have the special properties. It can store a lot of voltage. Okay, but I appreciate that you are thinking about this. How could we make our results more valid? At the end of the experiments, I wanted to see everyone in a group discuss, and I would like to see at least 2 answers from each group. Okay, I will give you this question. So I would like to spend some time for you. So could you please write down these 3 questions from the board? Okay. Yes. All right. Okay. Do you have any other questions? Maybe not now, but I'm here to help you. I'm here to monitor it, and I am here to learn from your experience. So if you can discover something exciting, please feel free to ask me, feel free to share with me. I would like to see how does it go and how does it develop the voltage. In particularly, I'm very interested to see which vegetable or fruits can produce the best battery. That means it should have the capacity to produce maximum voltage. Okay, before going to the what we learned today, I would like to go to the experiment, then I will be revisiting this. Now, I would like to go, just give me some second. I would like to share just give me a second again. Okay, so everyone got this experimental instruction sheet, which is fruit and vegetable battery. First of all, do not eat anything that was used in the lab. So these fruits are consumable, I acknowledged, but please don't eat. Okay, otherwise we can't do the experiment. Okay, so what to learn is basically how a battery works using electrochemistry. Okay, although this is the physical science because we are developing electrical energy, it's a form of energy. Now the copper electrons are chemically reacting with the lemon juice, which is weak acid. That's why I say that it doesn't matter. That's it's not harmful for the human body. And then copper ion interact with the zinc electrode, and that's where the voltage will be developed. And you see how the emitter works. So you see this one. Now if I connect with this fruits, this is the emitter, and you can easily monitor the voltage. It's pretty straightforward. Even if you feel any difficulty, feel free to ask me. I will help you. Okay, so the materials. Zinc strip, copper strip, 2 alligator wire, digital multimeter. Okay, now fruit for this experiment, that's we have lemon, lime, apple, potato, tomato, banana, and oranges. You already know the experimental procedure, but I would like to describe again for your understanding. At first, when you will take the lemon or citrus fruits, squeeze this, because through the squeezing, we can make it juicy. Lot of juice, lot of electrolyte. That means multiple voltage. And without breaking the skin, because if you do break the skin, the juice will be coming out, then you will lose some energy or electrolyte. Now, insert the copper and zinc strip into the lemon or any other fruits or vegetables. Put the alligator wire, connect straight with the emitter. You can easily measure the voltage. Okay. Now, what happens when you gently squeeze the lemon? Does the voltage vary over time? I would like to see your response. You need to fill in the data table as you test these different ideas. Then try potatoes, apple, or other fruit or vegetable. Record your measurements in the data table. What if you use one electrode in one fruit and one in another? What do you measure? So you need to respond in a group. As I said at the beginning of the lesson, this is a group lesson. You need to work in a group. Okay. So if you have any questions, feel free to discuss in a group. If you have still doubt, feel free to ask me. So this table need to be filled up. It's pretty straightforward. There is 10 types of fruits. You need to write down the fruit name, okay, and the generated voltage. Through these activities, we can easily monitor which voltage is the biggest, basically. So the largest voltage can be counted easily. Now, the science behind the experiment, I have described this is here. You already know about this. However, for your understanding, I have written down. So please read it, but not now. When you will fill up this report, this is the home task. You need to read, you need to go through this, and you need to develop your understanding. What will happen when we will have 557 lemons to light a standard flashlight bulb? Is it true or not true? Well, we are not going to connect 557 lemons, but from my experience, that's I did learn, if there is a good lemon, at least 557 lemon need to light a standard bulb like this, okay? Now there is the assessment of your understanding. This is a group assessment. Everyone will get the same mark. However, I will pass you another sheet where you guys will mark each other. How much mark you will give to your friend in a group. So everyone will mark to everyone. It will be interesting. And how much mark you will get, that will be multiplied by your group mark, so that everyone got on the same board. All right, everyone get good marks. Again, marking is not the main standard. I would like to see you are enjoying the experiments, you are learning new things, and I can promise you it will be really funny and interesting. So what kinds of fruits make the best batteries? That's I did told several times. That's I'd like to see. Do you understand how to understand? Oh, yes, from this table. That's right. Thank you very much, Mark. What happens if you put one electrode in one fruit and one in another? You need to write down. You may get more voltage, maybe less voltage, maybe nothing. What happens if you stick multiple electrodes? That's pretty interesting. Rather than putting one electrode, you can put multiple electrode and you can make a series connection, and you see what happened. That will be fun. Any other questions? Any other questions? No? Okay. Now your time to do the experiment. I will spend 40 minutes and take the safety goggles, and I would like to see which group makes the best battery. Okay, enjoy your time. And again, feel free to ask me any questions. We are here to learn mutually. All right, so every group has done the experiments. Congratulations. And you have your own data and you already responded the answer. That's great. Okay, I'm going to show you what we did learn today. So we did learn two different metals are needed in battery to make it work. Which two metals are best for fruits we already learned, and you already have your results. Now I would like to put the best results here from each group. So each group 1 to 6 will give me your best result and which fruits or vegetable get the best result. All right. Hopefully you did enjoy the lesson, and thank you very much. Thanks everyone. Bye.